Slags are byproducts generated during iron and steel production in the steel industry. Disposal, recycling and reuse of slags have been a major concern for steel makers. Slags are generated at two different stages of steel production, iron making and steel making, known as blast furnace slag or iron slag, and LD, Lenz-Donowitz slag or steel slag respectively. Generally, BF slags or blast furnace slags are granulated and used in cement making due to its high cementitious properties, whereas steel slags, due to metallic content and unfavorable physiochemical properties, cannot be used in cement making or any other industry. With increasing capacities, a major percentage of both these slags is dumped by all steel makers. The increasing dump of steel slag not only occupies land, but also has an adverse impact on the environment. JSW Steel has developed a sustainable solution to this global problem. Its R&D has developed a technology which converts both the iron slag and steel slag into fine aggregate for replacing river sand for construction activities. River sand is the most preferred and utilized as a fine aggregate for mortar and concrete. With ecological concerns and environmental restrictions, the availability of natural aggregates is greatly reduced and slag provides an eco-friendly alternative. These slags, as in their generated form, are not suitable for direct use in construction. However, the customized circuits developed helps in addressing the inherent issues in the slag. Based on these two new patented processing technologies, JSW Steel commissioned India's first iron slag sand plant of 1500 tons per day capacity and world's first steel slag to sand facility of capacity 800 tons per day at Vijayanagar Works. Both these plants are providing eco-friendly fine aggregate for various construction activities. Iron slag sand circuit consists controlled granulation followed by shaping in a vertical shaft impactor. When the molten slag is tapped from the blast furnace, the water temperature is closely controlled during the granulation to avoid the vesicular structure. This granulated slag is further processed in a vertical shaft impactor for shaping, sizing and removing the glass particles. In the developed steel-making slag sand process, the molten slag is first slowly cooled in pits with controlled sprinkling of water to accelerate the weathering process. The weathered slag is subjected to a series of crushers and magnetic separators to separate the metallic and non-metallics. This slag is then subjected to a vertical shaft impactor to break into smaller sizes, control the size and change its shape from angular to rounded. The product is further subjected to air classifier for separation of ultrafine fractions of less than 150 microns. This classifier product can be used in cement making, in concrete mixtures, as silicon fertilizer, as steel slag micro powder and as soil conditioner. The developed process breaks and exposes the free lime particles in the steel slag and further gets removed by the classifier, which reduces its expansive behavior. This technology addresses the inherent issues of steel slag, such as presence of fine metal particles, wide size distribution, and presence of expansive free lime, which made it unusable till date. These technologies provide complete solution to its sustainable usage without any rejections. Mortar and concrete cube tests conducted using the developed steel slag sand show improved strength when compared to the river sand. It was found that the use of granular slags has increased the packing density, which results in reduced water-cement ratio and increased strength properties. The rough spherical particles of granular slag also improves the bond and adhesion strength. These slag aggregates can be used individually and in combination with natural aggregates without affecting any concrete properties. Various studies have also proved that slags fall under innocuous aggregate category and therefore may be applied safely in aquatic environments such as rivers, lakes or streams without impacting water quality or aquatic life. Some of the key advantages of this sand over natural sand are no expansion issues as it's crushed and exposed, better strength than river sand and other alternatives, environmental friendly alternative, controlled physical and chemical properties, no deleterious material, available throughout the year, sustainable for roads, concrete, plaster, mortars, RMC plants, etc. Both iron making and steel making slag sand has been extensively used in various construction activities in JSW Steel Vijayanagar Works and outside as complete or partial replacement for river sand in bricks, pavers, blocks, tiles, pipe manufacturing, foundation works and concrete roads. In the market, The iron slag sand is preferentially accepted for mortar and plaster applications, and steel slag is preferentially accepted for concrete and road applications. This innovation is a breakthrough for the steel and construction industry. Effective utilization of these materials has tremendous economic impact, conservation of natural resources, and gainful recycling of processed byproducts.
The state-of-the-art slag-to-sand plant not only demonstrates our capability to reduce and recycle solid waste, but also highlights the efforts of the R&D group in developing a process that can generate value out of a waste stream. JSW Steel is executing its strategic growth plan in line with increasing global steel demand. The slag-to-sand technology that was developed in-house shows our commitment to achieve this growth in a sustainable way.